Hey everyone, exciting news. We've officially launched the Paranoid Perspective Patreon. If you love what we do, unpacking conspiracies, chasing mysteries, and laughing through the weirdness, now you can support the show and get more of it.
So, for as little as $5 a month, you will get exclusive access and extra perks to the episode. Sarah, what do we get with tier one?
So, tier one is the Curious Minds, and you get a shout out at the end of every episode.
Next tier, this is what you guys really probably want, ad free episodes. We don't need those pesky ads that you guys are getting on Spotify, Apple, whatever else. You will get all episodes ad free, along with what else, Sarah?
You'll also get it ahead of time. So before the episode releases for that week, it'll be available for you to watch or listen.
So, if you guys are interested, check in the show notes down below, or you can head to patreon.com/, the Paranoid Perspective Podcast. Welcome back to the Paranoid Perspective. I'm Jake.
And I'm Sarah.
Sarah, you turned me on to this last week, told me something about, or 2 weeks ago. And I'm honestly shocked I never heard about this, or hadn't heard about this until you brought it up to me. And it's kind of scary, but not really scary. Kind of just weird, I guess.
Yeah.
But in all honesty, I needed a little bit of a palate cleanser anyway, because we've been talking about some dark shit here lately. So we're gonna look skyward today. So we are going to talk about GD-1, the stellar stream today, and some funky stuff that's kind of going on with it. So you've heard about it.
Yes. I only saw a very small TikTok about I think it was just an image or something. And I
Yeah.
did not look up more than that, but
Yeah. Well, and it's one of those things too. Like I know I always, especially at night, if you're camping or something like that, like looking up at the stars and being like, dude, like it's wild. You know, you're in a
yeah.
place with like no white pollution and you can like actually see the bands of the Milky Way. Well, GD-1 is one of those like streams that you could possibly, I don't think you can see it with your naked eye, but you know what I mean? It's
Yeah.
like, it's
Right.
similar to what you can see, like the band of the Milky Way going across the night sky. And from our perspective, everything out there, dude, it looks pretty much like it's sitting still. You know what I mean?
Yeah.
Nothing
Right.
really going on, nothing crazy. But the universe and our galaxy is anything but that. You know, we sit here and everything's pretty chill and quiet and nice, and we're just enjoying a fire. But in reality, space is scary. You know, we've got everything from black holes to quasars to supernovae to, you know, cosmic collisions that like
Yeah.
it's insane when I kind of think about just how like unbelievably violent and chaotic the universe and galaxy is, and we're just here like, hey man, the moon looks really nice tonight. But
Right. Yeah. It's a little scary to think about, like on the large scale, but
well, and I think that's part of the problem with the universe or even the galaxy. It's too big for us to even like wrap our head around.
yeah. Right.
So
Yeah. What do you mean everything's moving together all the time? Like, I don't know. It's so hard to
well, and it's like
think of that too.
the second you start talking to like astrophysicists and stuff, and everything is like when you start to think about, well, everything is moving in, you know, relativity to what it's moving against and what's moving next to it, and it's like I'm not smart enough to talk about this, so listeners, don't judge me in the comments, okay? I'm kind of a dumbass when it comes to this, but I do like listening to it and I do like talking about it. But when we see stuff in space, it's like absolutely mind blowing. Like usually it's like I first thing that comes to mind for me is like the first images that they took of a black hole, you know, not too
Oh,
long
yeah.
ago, where it's like, so we like mathematically knew it was possible to have a structure like that, and now we actually have like a no shit photo of one, which is absolutely insane. And then to think of the scale of that, Like
Yeah.
when you start saying it's a million solar masses or a billion solar masses, like I don't know what that means. I just know it's fucking big.
Right.
You know,
Yeah.
you
Yeah, I
can't.
cannot comprehend. I can't even comprehend how big a whale is.
That's
Like,
what I'm saying. That's what
yeah.
I'm saying. Like, we were out in East Tennessee and saw a black bear, and most
Mm.
people had never seen one that were in the car with us, and we're like, "Holy shit, that thing's huge!" And it's like,
Yeah.
I mean, not really compared to other things, but I guess in comparison, sure, from what you don't
Yeah.
know.
Or when you first see how big a moose is,
Right.
like compared to a car, every time
Right.
it's like, what?
Yeah.
That's insane.
Yep. Yep. Yeah. But with GD-1, it looks like something moved through it. Something we can't see and something we definitely can't fucking understand. But when I say it moved through it, we're not talking like it just pushed out like a gas cloud out of the way or something like that. We're talking like a shit ton of stars and any other like material in that space of this entire stream of stars and stuff like that. Like that once again, something
Yeah.
unbelievably massive worked its way through, pushed all this stuff out of the way, and now there's just like this gap, I guess would be the best way to say it. I but looking at it, it's hard to really see that though too, you know.
Yeah.
So,
I mean, it kind of looks like a scar almost or something like,
yeah, I don't think that's entirely accurate though.
well, no.
After
Yeah.
doing a little bit of research, like I don't know, but I don't think that's entirely, what it is. But at first glance, the JD-1 or GD-1, I'm going to keep saying J for some fucking reason.
Yeah. Why are you saying Drake?
I don't know. Um, it doesn't really look like a whole lot. It's like kind of like, it's not like a bright nebula that you can see. It's not like a glowing cluster. It's something that you probably, like I said earlier, you can't notice with your naked eye. It's just a faint, narrow ribbon of stars stretched across the sky.
Hmm.
It, and when astronomers started to look a little closer at this, they noticed that something shouldn't be there, or more accurately, something wasn't there, which is even more disturbing. There was a missing section, like you said, kind of like a scarred out thing. And there was a strange formation nearby, stars that had been pulled out of the stream and displaced. Like,
Hmm.
not just that they were missing, but they had actually moved. Like,
Right.
so something passed through and like kicked them out of the way. I don't
Yeah,
know.
that's crazy.
Um, when we think about this, though, it's once again, we have to start imagining something that no longer exists because, like, when we look out into space, we've talked about this before, we're not seeing things as they are, but as they were.
Mhm.
Um, there was likely like a dense cluster of stars moving in the outer regions of the Milky Way, I think they call it like a globular cluster or something like that. I don't know if that's the most accurate term. Um, but it's not a loose group of stars that we see like out in the night sky. It's like a very packed, contained, almost spherical, like a proto galaxy, I guess would be the
Um,
best way to say it, you know? And some of these globular clusters contain tens of thousands, sometimes even millions of stars, and they're just bound together by gravity. So
oh wow.
these aren't small structures. You know what I mean?
Yeah.
When we think about it. I mean, I guess in the scale of a galaxy it is, but like it's not small. And some of these clusters are super old. Like, I mean, almost as old as like our galaxy itself. So, and for a very long time, they've remained pretty stable. Um, but the Milky Way does exert certain tidal forces as it spins.
Mm.
So gravity's pulling from different directions. It's kind of stretches, distorts, and sometimes it will start to push things apart. Or I guess tear isn't the right word, but you know.
Right. Yeah.
Um, but the crazy thing about this is like it's not something that looks like it was done over a long period of time. It looks like something just like plowed right through. You know what I mean? And
Yeah.
what could be that big that we don't see clearly that can have that big of a impact on a fucking part of a galaxy that we're just like, oh, whatever, you know. I don't know. But let's see what we got. If we were to kind of talk about scale, this is I didn't really want to do this, but GD-1 is roughly 25,000 to 30,000 light years away from Earth. That doesn't really mean,
Mm.
you know what I
Yeah, I
mean?
don't really get what, right.
And it does extend across a very large portion of the sky, and it's
Mhm.
only about 100 light years wide.
Oh,
So,
okay. I don't really get what that means either.
I,
Like, width wise.
well, see, that's the hard part too, because like we can't. It's hard to think about that like three-dimensional shape, right? As like that large of a thing. Like I can pick up anything on my desk right now and tell you that it's like, oh yeah, this is 3 by 5 by 1. You know what I mean?
Right.
But when you
Yeah.
start adding light years into the equation, it's just like, well, I don't know what that looks like. I don't. It's just,
That's
you
too
know,
much. It's too big.
too big. Um, but here's another important detail: when astronomers map structures like GD-1, they're not just looking at like where the stars are at. They're looking at how they're moving. They're looking at how fast they're traveling. They're
Mm.
looking at like where they will be over the course of time. So there's a
Yeah.
lot of modeling that happens when they do this, and they're, being able, and it's really cool because you can actually kind of track where things are going and how things will look in the future, but you can also kind of do the opposite and kind of figure
Mm.
out where stuff came from, or, you know, kind of get like an idea of the formation of galaxies and stuff like that. Um, when they did start to reconstruct JD-1 from a lot of the data that they had, they found that a lot of things didn't line up. Stars were missing. Clusters of stars looked like they'd been pulled out, thrown aside, kind of like I already said. And astronomers called this a spur. You can think about it as like almost like a debris field, I guess, if you like,
Oh,
you know what I mean. But it was definitely evidence of something passing through that sort of thing. Um, and that's kind of where it really begins as far as the mystery. Is it a nearby object? Is it visible in some way to us? As of right now, I don't believe so. Um,
yeah. Like, what would be doing that? Like,
I have some ideas, and they're pretty far out there, but
okay.
we'll save that kind of.
Aliens.
I don't think so, man. I think because
Nah.
that's like way too big for that, you know. But it's hard to think about how that is even possible to move. Like even just saying, how do you move a star? How would you just a star? How would you physically move it from its current position? You know what I mean? Like,
Right.
there's no.
Put a black hole close to it so it slowly, like,
I mean,
travels away, I guess.
maybe
Just
I don't know.
manipulate the black hole to be like a toe. Tow it
I
away.
mean, on paper, I'm sure it would work.
Yeah, I don't
I'll
know. You
write
can't get
a.
too close though, or it'll get
Yeah.
sucked in. Yeah. It's a very
Well,
delicate procedure.
it is a very delicate procedure, and controlling a black hole, I feel like, would be like riding the worst kind of like wild bronco you've ever tried to tame. You know what I mean? Like, it's
You
just
gotta
gonna kill you.
control it from behind,
Oh, okay.
like a tornado. It's like a tornado. I don't know. What does the other side of a black hole look like?
Um,
Is it like that? Like a funnel? Like
well, no,
tornado?
it's like, so the easiest way I've thought about black holes, especially like just specifically for them, is think about it more as like a gravitational well that you can't get out of.
So there's no way to
But in
be behind it.
no, no, because it's three-dimensional as well.
So it's sucking from both sides to
Uh,
a point,
Yeah,
or
everywhere
oh,
simultaneously going to a singular point.
okay.
So like they'll show it on like if you saw it on like a flat grid, that was three-dimensional, you would see a hole that starts to form, and then like it just gets stretched into an even smaller infinitesimal tiny tiny point. But you got to think
Right.
about that from if that shape was a sphere, not just a flat grid. You know what I mean?
Yeah.
So
So there's nothing behind a black hole, I guess, yeah.
yeah. Um,
Except the portal to another dimension.
or universe. You
Yeah,
never know. I mean,
right.
who knows? But I do kind of want to talk about like how it was mapped. The Gaia Space Observatory played a big role in that as well, and then kind of go back just a little bit to when scientists realized, like, holy shit, like the oh fuck moment. You know what I mean? Um, where was I at? See, here we go. Um, so the Gaia Space Observatory is one of the most ambitious space missions ever launched. Okay, are you familiar with it? What that thing?
Um, I don't think so. What is it? Is that what the, that's not what the, what is the new one
James
called? What?
James Webb. No,
Oh, yeah,
no.
right. It's not that.
Mm-mm.
Okay.
So it was launched by the European Space Agency in 2013, and its
Oh,
goal was to pretty much map the galaxy.
okay. No, I don't know anything about this apparently.
Yeah. Um, but not just like a static image. You know what I mean? It wasn't just pictures or whatever. It was measuring like position, distance, and motion for
Mm.
billions of stars. Like that's what
Oh,
it,
wow.
like that's why it was like such an ambitious project, because it's like that undertaking within itself. Like even hearing the word like billion, one
Right.
singular
Yeah.
billion, like that's insane. Um, but each one was tracked with incredible precision. Where it is, how far away it is, how it's moving through space. And with enough of that data, you can start to kind of rewind. And that's really what they wanted to do,
Mm.
is like try to figure out galaxy formation, especially ours, and how it was kind of formed. Um, and you can start to see like patterns when you see that. You can start to see the structure of the galaxy, how it comes together, different streams. For instance, like we talked about the band of the Milky Way. We talked about the GD-1. And you can find a lot of things that would otherwise be like completely invisible to the naked eye just by mapping out these, you know. And that's kind of how the JD-1 came into focus. It was identified years earlier. But Gaia turned it into something way different. Instead of like just a really vague ribbon of stars, it became like super precise, clear to find, trackable. It was great,
Mm.
right? Um, Astronomers started analyzing the data in detail, and one researcher in particular noticed something very, very strange. So, working with high precision data, um, her name was Anna Bon. Oh man, I'm gonna mess this name up. Bonica, I think is how you say it. Anna Bonica, I believe. Um, she and her team began to study GD-1. I swear to God, I'm going to keep saying J for some
Yeah,
reason.
you
I
keep saying J.
do
I'm just
not want.
ignoring it.
Well, listeners, I'm sorry. I'm just.
Anytime you say JD-1, he means GD-1.
I do. I do.
Just accept it.
Just accept it. I'm dumb. There you go. I
No.
don't know how to read. Um, they were looking at how they were arranged, like I said, and how they moved. And at first, everything seemed pretty normal, just a stream with a pretty predictable path, stars in alignment, kind of as they are in most galaxies. And then they fucking saw it. It was a break where the stream simply just stopped. It
Yeah,
it just
that's that would be so crazy to like see the first time, be like, what?
well, so that's the thing. Like I think it would be so awesome in those moments, but like all the work that they had to put in to just get to that point is
Yeah.
unbelievable.
Right.
And the amount of data they have to comb through and put together, and like and some of these people that do this research, like this will be like especially with like space probes and different things like that, like that's their life's work. Like they do
Oh yeah.
their entire
Right.
life is just getting this probe out into space and doing whatever it's going to do, you know? And then seeing something like that, dude, because you're already proud that you got it out and you're working and
Right.
everything's going. And the next thing you know, you find something that you weren't expecting. It's just like, I could not imagine the excitement
Yeah.
from that.
Right.
So,
Yeah, it makes it all worth it for sure.
I
Because
mean,
I assume that. Oh, sorry.
I was going to say, I think it makes it even more worth it because like
Right.
you've already accomplished the goal. Like you're getting the data that
Yeah.
you have worked for, you know, like that's the goal.
Yeah. Um, I assume this data is like readouts, isn't it? Isn't it just like a stream of like numbers and stuff? Like to
Yeah.
interpret it, I feel like that's so
Yeah, it's
hard
not
to.
you're not just going to Kinko's and getting a
Right.
printed out color picture. You know what I mean? Like
Uh,
it's
that's the future.
maybe, maybe. Um the thing is though, and I don't want to get this confused with anything, like gaps in these like stellar streams, like GD-1, got at that time, are not completely unheard of. You know, they can spread out, they can fluctuate. You might see like super thin sections where you know, stars might not be as detectable, but there still are some there, you know.
Yeah.
Uh, but this was like way different. It wasn't just like a low density region of stars. It was like a clean gap. Like a missing chunk was just not there. Um,
Yeah.
and more importantly, the stars around it were not behaving normally either.
Hmm. Like
So,
moving too fast or something, or
well, they were moving like they had been pushed off of their typical trajectory. You know what I
hmm.
mean? Like it wasn't like a I don't think like stuff was like rushing away, but it was like okay, this thing was clearly like bumped out of its typical orbit. Or not orbit. I guess orbit around the Milky Way, but yeah, you know. And with that displacement, they were like offset from like the main line of where they should be in that orbit around the Milky Way. And if you visualize it, it literally, from what I've been gathering, it looks exactly what you would expect after an impact. You know what I mean? With like debris scattered, you know,
Mm.
off to the
Yeah.
side. So, I mean, I guess it's kind of hard for us to picture that in like, you know, four-dimensional space, but I mean, I guess that's the best analogy is like if, I don't know, you had I don't know, like a line drawn in the sand and you threw a rock and it hit the line. You know what I mean? Like you would see the line had been split, but then you'd also see like this debris that came
Mm.
out from it. So,
Yeah.
um, now with that, this kind of stopped being a mapping project and started becoming more of a fucking investigation of like
Right.
what in the fuck just happened here. You know what I mean? Because there weren't just like new questions, there were fucking huge questions. Like, you know, what could create a gap like this? What could possibly pull stars out of alignment uh, without completely destroying like the entire stream of stars? You know what I mean? Like if it's
Yeah.
that big, you would think there would be more of like a, I guess, a hole in it, you know? And if it is something that big, like how massive does it actually have to be to leave something like this? And the worst question of all, not what is it, but where the fuck is it? Because we can't see
Yeah,
it.
where did it go? Right. Yeah. I mean, it's pretty far from us though, right?
No, yeah, I mean, I don't think it's careening towards us by any means, whatever it may be. Um, and the thing is too, like we're in like a really good part of our galaxy, like kind of like I've always heard astronomers refer to like we live in like the suburbs. You know what I mean?
Right,
We're
yeah.
we're not, you know, we got the white picket fence and you know friendly neighbors and stuff. That's kind of where we're at in the cosmic neighborhood, I guess would be the best way to say that. Um, but the good thing is we do have a lot of computer-based simulations that astronomers use to kind of help answer these questions. Like we can plug in variables, figure out like, well, what would it have to be to do this, and how would it move, and how would it interact? And it's almost like solving a crime. You know what I mean?
Mm,
If you didn't
yeah.
see it happen, you only have the aftermath. You got to figure out what actually happened. And that was literally the exact situation that Anna and her team kind of started going through. Um, so the real question, it's like trying to figure out like what kind of object it was. You know, they started simulating with different scenarios. What if like a star had passed by? If another cluster
Mm.
maybe had moved through? What if like a massive object at super high speed hit right through here? They were constantly running these over and over again, changing variables, adjusting mass, velocity, anything you could to pretty much figure out like what it could be. And they did this over and over again until the results matched exactly what we observed.
Oh. So they know what happened,
I don't,
basically?
no,
Oh,
nope,
okay.
nope.
But they found a good match.
Well, sort of. So
Okay.
what they found was very, very specific. Okay. But it's not going to be anything that's going to, you're not going to like it. Okay. It was extremely massive, like we already know.
Mm-hmm.
It was moving very, very fast, which we already know. And it was invisible to any observational data.
So it's like dark matter?
Possibly. That is
Like
one
a
of the theories.
cluster of, okay.
That is one of the theories. And we'll get into dark matter.
Yeah.
Here's the thing, though. The simulation suggested an object had to have the mass, quote unquote, millions of times the mass of our sun.
Oh, really? Millions. What's the mass of our sun?
See, this is why I don't do this for a living. That's why I just talk shit on a podcast.
1.989 times 10 to the 30th
Yep,
kilograms.
sounds good to me. Don't know what that means, but we're going to go with that.
333,000 times the mass of the Earth. So,
I still don't
would
know
you
what
say
that
a
means.
billion times more than that? Or no,
Millions. Millions.
a
Millions.
millions,
It doesn't say
multiple
specifically.
million.
Yeah.
Oh, be 10 or it could be 999.
9,000.
Like, what?
Yeah.
Yeah. What?
Yeah.
Tell me
Uh,
what millions means. Okay. So times 333,000 times a million.
Welcome to the math portion of the podcast, listeners.
Yeah, isn't it so exciting?
It is.
Okay, well, yeah, that's massive.
I'm
That's the
gonna
conclusion.
go. I'm gonna go with my awesome math skills and refer to it as big as shit.
Yeah. Well, I mean, we've definitely observed bodies of celestial bodies, I guess, bigger than the sun.
Oh, 100%.
But I
Yeah.
guess, have we ever observed something that big, though? I don't think so.
Well,
Like
structures,
its own,
yes.
well, right. Yeah.
Yes. Like we were talking about earlier, like those clusters or those like proto galaxies or something like yes, there are structures that are significantly bigger than anything we can imagine that we can and have observed.
Right.
Um,
But
the
not a
thing,
single thing.
no, no, not like a
Yeah.
single object,
Right.
which makes sense because I think at some point, if it was that big and it was a single object, like I'm just thinking off the top of my head, it'd be it like made like a black hole. Like that means it's swallowing like galaxies. You know what I mean?
Right. Yeah. What's the biggest black hole we've seen? Definitely not
It's either
that big.
Phoenix A or Ton 416, I think. I can't remember which is bigger. It's one of the two.
Sorry, I'm derailing.
No, you're
What
good.
really
You're good.
big is black hole? Phoenix A.
Okay.
Its estimated mass of roughly 100 billion suns.
Oh, that's
So
yeah. Yeah,
that's a lot bigger than this thing.
it's a lot
But
bigger.
yeah, it probably wasn't a black hole because then everything would be gone. And
Well,
it would still be there, wouldn't
and
it?
we'd be able to observe it if it was a black hole.
Right.
We'd be able
That's
to
true.
see the distortion of space time that has like a halo that you can see.
Right.
Or if it is interacting with matter, you'll be able to see the accretion disk forming around it. So you
Right.
would be able to see something. You might not be able to see the black hole itself, but you'd be able to see what matter's interacting with it.
Well, and I think if it was that close to, I mean, it went through our galaxy, whatever this was. Like, that would be I mean, I don't know what we could do about it, but that would be like national news.
Not a
Like, that
damn
would be
thing.
something. Well, right. But if a black hole's that close that did that, like,
Maybe it's a not maybe it's like a don't look up scenario right now. Maybe
yeah,
we're living through like a we're
they know and they're not telling us. Yeah.
yeah.
About to
Yeah.
see the black hole on the horizon.
I mean, I think
I
if
don't even think we'd see that.
no, I don't. If it's that big, I think
Yeah.
you probably, and honestly, if it's that big, I don't think you would even notice falling into it, like going past the event horizon. Like I honestly don't think so.
Yeah. Maybe we're already in it.
I think we are. I think we're in a black hole. No, I think our universe is we're in a black hole. That's just my
Right.
opinion. Either
That's
that or
what's causing the Mandela effects.
maybe, maybe. They very well could be. Hey, listeners, hark back to the Mandela Effect episode. It's a really fun one. You should check that one out after you listen to this one, of course.
Yeah.
But like I said, it was fucking big. It was moving hundreds of kilometers per second, um,
Wow.
and completely invisible. Like
Yeah.
we couldn't. The only thing we could detect is the aftermath of it. You know, and nothing in other follow up observation really lines up with like a conclusive. Yep, this is probably what it was. You know what I mean? We're either missing something completely here, or we don't understand something, or we're dealing with something that doesn't emit light at all.
Yeah. That's very strange. Yeah.
Which I think all three of those are probably true. Because fucking space is big, man, and we don't fucking understand shit. We don't understand shit about it. You know what I mean? We just
Well,
live
yeah.
in it.
Yeah.
You know?
Yeah. We haven't seen majority of what space can do. Like,
Yeah. Well, and I'm not trying to say we don't understand any of it, because yes, there are very talented people that understand a lot about it. But what I'm saying is it's kind of like that'd be like a layperson picking up like a glass of water out of the ocean and being all like, "Yep, that's the ocean." You know what I mean? Like,
yeah, technically true, but
yes,
there's still, yeah. And we can't, I mean, unless it happens nearby us, I mean, there's probably a million things that are happening that we have no idea because we can't see it that
well,
far.
that, and there's probably a million things happening that we will never see because the
Well,
light
yeah,
just will never get to us. You
right.
know, so
Yeah.
but there is something that makes up most of the matter in the universe, and you alluded to it earlier, which is dark matter. Now, we cannot directly observe this. Um, and this is predicted by the CDM model, but it's never kind of been confirmed. I think a lot of people are really, they're not confirming this, but they're really thinking that that's what we witnessed, was some sort of interaction with matter and dark matter. Now,
Hmm.
that's up for debate. I am not smart enough to have, those sorts of discussions. So I'm just going to go with kind of what people that have spent most of their adult life studying and researching, kind of on that. But if we take kind of like a little bit of a deep dive into dark matter, just a little bit, it kind of starts to make sense a little bit. When we talk about it, dark matter, sorry, I lost my spot in my notes, is definitely, it's invisible, and it is a hypothetical form of matter. Like, I want to make sure that's clear. Like, it's not anything. It's just like you could literally just call it stuff, and it's not going to
Right.
change what it is. You know what I mean? We
Yeah.
just assigned a name to it to make us, make it make sense. But dark matter is implied by the gravitational effects that cannot be explained by general relativity unless more matter is present than what can be observed. I forget what it is, but like, Um, if you, like parts of like the CDM model that I kind of talked about, which is the cold dark matter of like have you ever seen that like big blown up picture of like the cosmic microwave background?
Oh, yeah.
It's
Yeah.
kind of what we're talking about here. Um, 5% of the universe is ordinary matter, like you and me, this desk that I'm sitting at. 26.8% of the universe is dark matter.
Okay. What's
And
the
the
rest of
other
it then?
68.2 is a form of energy called dark energy.
Oh. I don't know if I've heard of that. Dark
So,
energy.
dark energy is a proposed form of energy that affects the universe on the largest scales. Its primary effect is driving in the acceleration of the
Mm.
expansion of the universe. Um, it also like slows the rate of like certain structural formations. So
Oh,
it's kind of like what's
okay.
pushing everything out. We can't figure out why everything's being pushed out. So once again, it's kind of the same as dark matter. We could just call
Right.
it the thing, and
Right.
it's
The
it's
thing that
it's
speeds it up or slows it down. It's too
yeah.
long. Too long of a title. Yeah.
But that's the crazy part. Like, and I always think it's insane to think that 95% of the mass of the universe is something that we have no way of detecting,
Yeah.
measuring, observing, anything.
Right.
You know what I mean? Like,
Yeah,
yeah,
it
we can.
doesn't it's not on any scale of like to see it at all, like with
Well,
like other instruments or
I,
something?
I don't believe so, but it's like you can see like what it does. I
Right.
guess would be the
So
best
it
thing,
has to
or
exist, I guess, or
yeah,
something.
or if
Or
you like, you
something
can,
has to exist.
or people have like when they've mapped out other galaxies, like, and you like start to run the numbers, there should be like significantly more mass for that galaxy to stay
Mm,
together. You know what I mean?
right.
Like if with the amount of mass that that galaxy has, like everything would just fly apart from each other, but somehow
No.
it's staying together. So there has to be some extra mass that we can't see
Right.
holding it together. So,
Yeah. Like a soup
yeah.
broth.
Yeah. Yeah. And you can kind of start to see this, and I mean you can't see it, like I said, not directly, but you can see it with like stars, planets, galaxies, all of it combined. You can start to see like a small fraction of like how it kind of works, you know. um it doesn't technically have mass though. It has gravity, but like let's once again, it's like how does that, doesn't make sense to us, you know what I
Right. You
mean?
kind of need mass for gravity, right? To
Right.
I don't
Because
know.
like,
Yeah.
because more so what you're observing is the gravitational effect. Like you're like, there should
Right.
be more mass there, but there's not. So that's like what they're calling
Right.
dark matter. You know what I mean?
Mm.
Now, as far as like what this has to do with GD-1, this is kind of just like a, an educated guess, I guess would be the best way to say it. You know what I mean? Um, a lot of stuff like this has been proposed decades ago about how stuff, forms and moves and stuff like that. Because a lot of galaxies, like I said, don't behave the way they should, and the easiest way is to say dark matter. Now, I've had a few people I've talked to about this where I've kind of gotten to like, I guess more of a theological debate with it, because they'll say something like, "Oh, well, that just, I mean, I could just say that's God," and I'm like, "Well, yeah, you can, but it's like I'm not. I don't think science is gonna like once they figure out what it is, they're not gonna say, oh, they're gonna have more stuff
Right.
to add to it. You know what I mean?
Well,
Like
yeah.
it's
Right.
kind of like that God of the gaps argument, I guess, would like it's God until we understand it, and then it's what we understand it as, and the next thing above it is God until we understand it, and that's
Well, yeah.
you know what I
Or
mean?
like magic. Like
Right?
once you figure out the science behind it, it's not magic anymore. It just seemed magical or like unexplained. But
Yeah,
yeah.
yeah. But part of the thing that a lot of people notice in these galaxies is like stars are moving like way too fast, like in their orbit around the center
Hmm.
of galaxies. And if they were moving that fast without that extra mass, they would literally just,
Oh, just be
rip
flung
themselves
off.
apart.
Yeah.
Yeah.
Right.
Yeah. Um, there is a really cool thing. You can think about like a massive halo over galaxies, and that is how you can kind of think about dark matter, like a massive like cloud that's kind of
Hmm.
keeping everything together. And I think that's one of the best ways that every time I've seen like visualizations of this or something, um, these halos extend like super far beyond like the visible structure of the
Yep.
galaxy itself. Um, and with these halos, there could be like smaller clumps where it's like much more dense.
Hmm. Right.
And if we have like i- invisible concentrated mass moving through the galaxy, that could be what passed through GD-1 and give it exactly what we see. You know what I mean?
Hmm. Yeah, kind of like a big ripple went through or whatever. Like,
Right. Yeah. Or, I mean, you could even think about it as if you wanted to think about like a proto galaxy, but you just can't see it. You know what I mean?
yeah, right.
It's just,
It's being formed still or whatever from,
yeah, it's just a
yeah.
massive object that we can't detect that just kind of
I mean,
punched us a little bit.
it's kind of like air turbulence or something because you can't really see. I mean, I
Yeah.
think some you can see, but there's ones that just look like, and then you fly through it, and it's like, oh, like, oh shit. It's kind of like that, I guess, unless,
Yeah. Yeah. Uh,
yeah.
if, if though that this interpretation is correct and it could be dark matter, the other thing is like these structures of dark matter have to be like pretty uniform because the universe itself
Mm,
is relatively uniform as far as its distribution of mass. You know what I mean?
yeah, right.
So there wouldn't be just one kind of dense spot. There'd be
Yeah,
billions, trillions, however, there'd be a shit ton of small dense spots of this dark matter that would be everywhere. And I kind of think that's just a little bit crazy because they're massive, unseen, and just hanging out. You know what I mean?
yeah, that's a little scary. Like, one could be on its way, and we would just not know. I mean, we would never know because it would just smack us out of, like, I
Well,
don't know.
but the thing is, I don't think. See, and I'm not smart enough to have this conversation, but I don't. Dark matter and matter don't interact. Like dark matter will pass through. You know what I mean? You'll see
But
the
it
gravitational.
displaced it,
Yeah, yeah. You'll see the
so we could
gravitational
get
effect for sure.
right. Yeah, we could just get like pushed aside from, and then just, oh, we're done
Well, but
from.
I think it would probably push the star, our sun,
I don't know,
with
maybe
us.
push it too close though, or something. I mean, it would totally change the
Yeah.
orbit. So, and then it was just like we have no idea what just happened. We just got smacked by space turbulence.
Smacked by space turbulence is the name of this episode.
Just smacked our plane to the ground.
Yeah.
Like, I don't know.
Well,
Space.
and the cool thing about like GD-1 is this isn't just about like a stream of stars that we observe something crazy. It's kind of confirming something that has only ever existed once again in theory. Like it's like kind of like the black hole when we took a picture of it, right? Like that's why that was such a
Mm,
big deal.
yeah.
Because for decades we've believed, well, scientists have believed that dark matter forms like a structure. It's not smooth, it's not evenly distributed. It's kind of clumps up in certain spots. And detecting these clumps is damn near fucking impossible. They don't emit light, they don't interact with any telescope or imaging or any detection that we have, and they don't show up in images unless, like I said, they're interacting with something that does. And that is
Right.
exactly what GD-1 could be. It could be our detector, so to speak, of this incredibly crazy phenomenon that we have no idea what's going on. Um,
Yeah. I wonder if have they, I mean, I wonder if they've seen anything else like it. When, because they were mapping our whole galaxy, right, with that program.
yeah.
I wonder if they'll find anything in the future that's like in a different spot that kind of looks the same.
Well, every time we get something new up there, like James Webb, for instance, like
Uh-huh.
we learn so much so quickly, and it's so much information to get through that it's hard
Yeah.
to, you know, get it all out. So I'm almost positive that they have found some crazy shit. It's just they haven't, you know, gone through the data yet. They haven't, compiled everything. I'm like, the thing with technology too and us is like we're always moving forward. So we're
Yeah.
gonna, I don't know. Um, if we take this one step further though, kind of to add on to what you said, if GD-1 was hit by like a glob of dark matter, um, this was just one example. There should be thousands of these. They call them
Right.
subhalos.
Yeah.
Because, like I said, you can think about the halo or cloud around a galaxy, and then you have these little sub ones that just kind of move through. But yeah, scientists determined too that there should be thousands upon thousands upon thousands of these moving through the Milky Way galaxy.
Right.
Now, that's not as bad as I think it is because, like, now we're getting into numbers that we kind of can understand. You know what I mean? Like, if you told me that there
Yeah.
were, if you told me that there were 250,000 of these things in the galaxy, I'd be like, okay, no, whatever. That doesn't really affect me because the likelihood of us running into one of those is pretty low. You know what I mean?
Well,
But
yeah, right. For the scale. Yeah, if there were billions, then it's like, well,
yeah,
we're gonna see the effects pretty soon if that's
yeah.
like, yeah.
Now the unsettling part is once again, like we talked about, invisible mass, and some of these could have be millions of times denser than the sun.
Mhm. Yeah.
Interacting only through gravity, leaving disturbances. What those disturbances create, hard to even tell what it would do. You know what I mean? Um, the simplest explanation based on what we know though is probably dark matter, if we're being real. Just because, or whatever dark matter is, whatever name you
Yeah.
want to give it. Um, but some scientists haven't stopped there because even though dark matter is like the leading explanation, it's not the only one. There are some other possibilities and theories that are kind of floating around out there. Um, the I don't know. I'm gonna go with one of these is kind of out there, but one of these is kind of real in my opinion. Um, so are you familiar with like super voids out in space? Like there's these massive like dark spots where like no stars are at all.
Yeah.
Like
Yeah. And we don't really know why either for that.
yeah.
Yeah.
Um some people think that like not only is our universe massive and huge, but it's just part of like a multiple universe where we're kind of like you could think about it as like a bubble, and
Mhm.
sometimes another universe like the bubbles will hit, and that's what'll
Yeah.
cause those voids to happen, kind of like a bruise, I
Hmm.
guess
Yeah.
would be. Now that being said, there's absolutely zero evidence for this. I am
Yes.
just speculating. Other people are just speculating. This is just kind of like the fun part. Now there are people too that say it could have been a rogue black hole.
Mhm. Okay.
Now this is a black hole that is just roaming through the universe, not fixed to anything, just out there living its best life. And the worst part
Yeah.
about rogue black holes, you can't see them until they start interacting with matter.
Right.
And if something that big, like a black hole, is just out and about, going for a stroll,
Yes.
pretty fucking terrifying.
Yeah, that would be pretty scary. Like, I mean, we would be able to see that coming, I guess.
If it started interacting with matter, we might be able to see the effects. I think it's called an Einstein ring. The
Hmm.
ring around the black hole that actually distorts the space and time from just the gravity of the black hole itself. But if it's headed our way, there's no way we would.
Well, we
It
can't do
just
anything about it, but
no.
they'd be able to observe it. I mean, there's plenty of matter
It's
to
true.
interact before it got to us. And I don't know how fast it would go, but it can't be faster than speed. Like should be able to see the distortions
Yeah, it does
before it
have
gets here.
regardless of how fast it goes, it can't travel any
Right.
faster than the speed. It can't fast travel any faster than right up to the speed of light because it has
Right.
mass. So
Yeah.
uh, the thing about it though is like if that was what caused it, they would influence their surrounding, but they would also bend light. They would create like
Right.
detectable gravitational effects, not just stuff being pushed out of the way. Like you would be able to kind of like track it, if that makes sense
Right.
a
I
little
would,
bit.
yeah, I would think so. You'd be able
Eh,
to see that is
yeah.
there. I mean, I don't know.
Well, and when astronomers were looking for stuff like this, because I think this was one of the first ideas that kind of came out from people, like there was no detectable anything for a black hole. Another one, this is kind of fun, a hidden dwarf galaxy. Now, dwarf galaxies are super small, faint, often orbiting larger galaxies like our Milky Way.
Yeah.
They're so dim that they're like super hard to detect. So, like, we could
Oh,
have these like satellite galaxies, little dwarf ones that we can't detect. You know what I mean?
hmm. Yeah.
And here is the important thing, like we just talked about. Not only do they contain visible matter, they also contain 95%,
Right.
or I guess not 95, but 20 some percent extra of dark matter, right? Now, if one of these dense dwarf galaxies were passing through GD-1, it could create a disturbance. But once again, we've looked and we're not seeing anything resembling a dwarf galaxy. So,
Right. Yeah,
no
I feel like you'd still
stars.
be able to see a little bit.
Well, but
Like,
that's what I'm saying. Like if you were looking for it,
well,
you
yeah.
know what I mean? Like you might
Yeah.
not be able to see it if it was just off in the distance, but if you like, okay, pretty sure this is what it is. This is where it should be, not there.
Right.
So
Hmm. Well, I guess they don't know when it happened
that's true. But
because it
you would
could have
still,
been already.
but you're still seeing that as it was too, that far away. So you would, you know what I mean? Like there would still be something, some,
Yeah, but if this event happened like 20 million years before, like, I don't know when we looked at it. Like, if it had already happened in ancient history, by the time we look at it, we're only going to see current. Like, not
well,
current,
well,
but
yeah,
for us, current.
yeah. Well,
Like, if it happened a long time ago, I guess it could have passed through and then we wouldn't see
that's possible. Yeah.
I don't know.
Yeah. I don't know. I'm not really buying the like dwarf galaxy or black hole thing because I think it would actually be detectable. Um, this one is a little bit less grounded in anything. Um, it could be something that we haven't even identified yet. You know, maybe it's not dark matter. Maybe it's not a black hole. Maybe it's not a galaxy. I mean, this is just pure speculation. Like, there's no way to even,
Right.
like, you know what I mean? Um, there is absolutely no way this is grounded in any sort of established science, but one of my favorites is like I kind of already talked about, like a bump from a different dimension or a different, you know, universe that just happened to knock into ours. And now we don't know what to do with it. You know what I mean? Because like
Right.
if it was like a distortion from like let's say a fifth, sixth, seventh, eighth, whatever number dimension above us, you wouldn't even know what you were looking at. You know what I mean? It'd be
Yeah. Right.
so mind-blowingly wild, and you wouldn't even see the whole thing. You would just see the portion of it that is visible in three dimensions, or I guess
Right.
four dimensions, but you know what I mean. But that's I kind of think it's dark matter. I think we finally got to see like a no shit effect of what dark matter does when it is like clumped together and hits and interacts with other
Right.
matter. Not interact with matter, because it doesn't interact with matter, but the gravitational effect versus the matter's gravitational effect, I guess would be the best way to say it.
Yeah.
So,
Yeah, I feel like from everything we know, that's definitely the most likely. Oh. I mean, it definitely could be something that we've never encountered before and we just don't know. I mean, you just don't know what you don't know. If it's something that literally we don't have any clue and some unknown thing that the universe does that we've never seen. But
yeah. I mean, that's,
from what we know, yeah, I think the dark matter is probably, like you said.
I think dark matter is pretty likely. I
Yeah.
don't really know for sure. And like I keep saying, I'm not smart enough to have these conversations. I'm just a lay person looking at stuff on the internet. Sarah sent me this via TikTok, so that's where we got most of our research from.
That's really interesting to think about, though. Like,
It is. Yeah.
yeah,
I do enjoy one of my favorite I guess what would be the best way education communicators is a guy named Brian Cox. He's really entertaining, really fun to listen to, really brilliant astrophysicist and stuff like that. So I like listening to this stuff all the time. I can't wait for probably like a year or two from now when like more people are talking about this, when research is like concluded and there's a lot of data to pull from and stuff like that to
yeah,
figure out what random people on TikTok think versus what somebody based in
yeah.
academia
I'm sure.
thinks. You know what I mean? So
Yeah, I'm sure it's gonna be very different.
yeah, yeah.
But
But
yeah,
I, that's what I got for GD-1.
nice. Yeah.
Um,
Yeah, it's really interesting. I'm trying to find images, but I can't really find beyond
yeah,
the image I sent you, I guess.
yeah. It's kind of hard too, because like you said, it's not like you're not getting an image when you get this data back, so you're kind of
Right.
having to like reconstruct and analyze and do all that. So, but
Yeah.
yeah, so listeners, if you happen to get on TikTok, I'm sure there's more videos on TikTok than there are anywhere else right now. You can see some cool, probably AI generated photos of it. I don't think any of them are real, but
Well, yeah, right.
yeah.
Yeah.
But yeah.
Thanks.
So, listeners, hope you guys enjoyed the episode. If you guys want to check us out on any social media, just type in the Paranoid Perspective Podcast. It'll take you pretty much everywhere. Um, check out our Patreon at patreon.com/the Paranoid Perspective Podcast. Got some extra little perks over there. Sarah, we got a super awesome thing for an Amazon product
Yes.
to kind of
Yeah, I'm
push
ready
today.
this time.
We're
Yep.
ready.
Yeah. I got my blue light glasses. So it comes in a case. Actually, I bought two of them. Well, I didn't buy them, but they're from Amazon. Yeah, and they're cute. Well, they're just blue light.
Yeah.
Maybe I
Well,
should be wearing them every time. I only do it when I know I'm working a lot on the computer, which is basically every day now. But not for recording. I don't know. But
well, it's the same thing. But yeah, listeners, if you guys are in front of a computer, I mean, hell, they even work for phones and stuff too, I'm sure,
oh
right?
yeah.
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 So
So
might not be a bad
yeah.
idea to get yourself some stylish glasses from old
They're
Amazon.
cute. And yeah, so the link will be in the description. We will get a commission at no extra cost to you.
Yeah. Yeah. So if you enjoy the show and you want to help us out and you don't want to check out our Patreon, hit that Amazon
Yep.
affiliate and that's the easiest way. But the easiest and free way for those of you that just want to help support the show, share this podcast with a friend. Any content you see, like it, comment, share, all the good social media buzzwords. And as always,
Remember, just because you're paranoid doesn't mean they're not watching. See you next time on The Paranoid Perspective.